Have you ever wondered how huge companies make these massive billion-dollar bets on the future? I mean, they don't have a crystal ball, right? Well, it turns out they have the next best thing, simulation. Today, we're going to dive into how this incredible technique lets us basically imitate reality, run thousands of experiments, and make way smarter decisions, all without any of the real-world risk. Let's get into it.
All right, so first up, we have to talk about the core challenge that pretty much every business leader faces. It's what we call the prediction problem. How in the world do you plan for a future that is, completely unknown?
I mean, this is the ultimate high-stakes question, isn't it? Just think about it. You're launching a brand new product, maybe building a new factory, or shoot, even just deciding how much stock to order for next month. Every single one of those decisions is packed with a ton of uncertainty.
Let's make this super real with a classic example, the inventory problem. If you're a retailer and you order way too much stuff, well, you're stuck with a warehouse full of unsold goods, and that's just wasted money. But on the flip side, if you order too little, you run out, and you lose out on sales you could have made. It's a total catch-22. So how do you find that perfect sweet spot? Well, this is exactly where simulation swoops in to save the day. It's a technique that lets us play out all of these different scenarios, not just once, but hundreds or even thousands of times inside a computer before we have to spend a single real-world dollar. It's kind of like a flight simulator, but for business decisions. So the key here is that we're not just, guessing. We are building a digital twin, a model that is designed to act just like the real system. And once we have that model, we can run experiments on it over and over and over again. It's basically trial and error, but in a world where the errors cost you absolutely nothing. And the advantages here are just huge. You can tackle these incredibly complex problems that normal math just can't solve. You can test out a wild new company policy or a new product without actually risking anything. But honestly, the best part, all the experiments, all the what-ifs, they all happen inside the model, not in the real, very expensive system.
Of course, it's not a silver bullet. Building a really good, accurate simulation model can be pretty expensive, and it definitely takes time. And it's super important to remember, this isn't some magic optimization tool that spits out one perfect answer. The results are an approximation of reality, a really, really useful one, but still an approximation.
So how do we actually do this stuff? Well, one of the most famous methods has a name that sounds like it's straight out of a James Bond movie, the Monte Carlo method. And it's all about using the power of pure, simple randomness to solve really complex problems. And yep, you guessed it. It is named after that Monte Carlo casino. Just like a spin of a roulette wheel, this method basically harnesses the power of chance. By generating a bunch of random numbers and seeing where they land, we can simulate what might happen in these incredibly complex systems. It's a surprisingly simple but really powerful idea. The process itself is actually pretty straightforward when you break it down. First, you figure out the odds of different things happening based on data you already have. Then, and this is the really clever part, you create buckets for your random numbers based on those odds. So, bigger probabilities get bigger buckets. After that, you just generate a ton of random numbers, see which bucket each one falls into, and you just keep doing that. Finally, you look at all those results to find your answer. Okay, theory is cool and all, but let's actually see this thing in action. We're going to go back to our inventory problem, and we're going to use the Monte Carlo method to figure out what the average daily demand for our product is. So, step 1. We start with what we already know. Based on our past sales data, we have the probability of selling a certain number of items each day. So for example, there's a 50% chance we sell 30 items, but only a tiny 1% chance we sell 0. This real-world data is the foundation for everything we're about to do. Now here is where the magic really happens. We translate those probabilities into our random number buckets. See, since selling 30 items has a 50% probability, we give it a massive range of numbers, from 36 all the way to 85. But a really unlikely event, like selling 0 items, it gets a tiny range, in this case, just the number 00. This right here, this is the heart of the whole Monte Carlo method.
All right, our model is built. Now comes the fun part. We're going to generate 10 random numbers, one for each day, to simulate what our demand might actually look like over a 10-day stretch.
And here we go, the simulation is running. Let's just trace a couple of these so it makes sense. On day 1, our random number is 40. We look back at our table and yep, 40 falls right into the bucket for a demand of 30 units. Now, check out day 3. The random number is 87. That's in the 86 to 99 range, so our simulated demand is 40 units.
We just do this simple matching process for all 10 days. So after running our 10-day simulation, we just add up all the simulated demand and divide by 10 to get the average. And what do we get? Our simulation suggests an average daily demand of 22 units. And just like that, the business has a data-driven, much more reliable number to use when it places its next inventory order.
So look, that was a pretty simple example, right? But this exact technique is used all over the place, often running millions of times, to solve some incredibly complicated problems. So let's zoom out and just see how simulation is quietly shaping the world all around you every day.
This stuff is a true workhorse of the modern world. It's used in finance to model investment portfolios, in logistics to figure out the best routes for shipping fleets. It is even used to design the checkout lines at your grocery store. I'm not kidding. Simulation helps figure out the perfect number of cashiers to open to make sure you don't have to wait too long.
And that kind of brings us to our last thought for today. Simulation gives us a superpower, of sorts. The ability to experiment with the future, completely risk-free. It lets us ask, what if, on a massive scale? So my question for you is, if you had this tool, if you could run a risk-free experiment on absolutely anything, what would you simulate? What big, uncertain question would you finally try to answer?